want us to look at how we can use product rule to solve differentiation question. Product rule is one of the techniques that you can use to solve some differentiation question apart from composite function and quotient rule. Now, when do we make use of product rule? What is the formula for product rule? I'm going to first of all provide you with the formula of product rule. The formula of product rule is the y dx will be equal to v du dx plus u dv dx. That is a formula to use when you are making use of a product rule. Then, how do we identify a kind of question that we're going to apply this product rule for? We will apply product rule for a kind of question whereby the values are multiplied with one another, and we discover that by their expansion might not lead to forming a polynomial. For instance, I'm going to provide a question now which will see that their expansion might not lead to the formation of a polynomial, or even if we want to try it, it's going to involve a lot of tasks. So let's look at the question that's going to help us in identifying how we can make use of our product rule in solving our differentiation question. Now, I have a question here. The question says, find the y dx if y is equal to root x into bracket x plus 3 for the bracket square. Now, you will discover that this root x here can as well mean y is equal to x raised power of half, then multiply by x plus 3 is about 2. Now, if you are to simplify this question here now, you agree with me that you need to firstly expand this value here. After you have done this expansion, you now try to start multiplying each of them by this. After which you now, in fact, it's not going to be a good approach when you are trying to answer your differentiation question. Now, let's try to solve this question right now. So we are going to now take the first value to be our u. You know, when you are reading your alphabet, you mention u before v. So let the second value be our v. Take note of all these things. They are very important. Even the formula v du dx plus u dv dx. Take note of them very well. Now, after you have assigned this value like this, then you can now start with if u is equal to x raised power of 1 over 2, du dx will be equal to what? Half x raised power of what? Minus 1 over 2. That is the value of du dx. So let's underline that. Now, then if v as well is equal to x plus 3 raised power over 2, then the v dx, if you make use of composite function to simplify this value here, we are going to have the v dx to be equal to 2 into bracket x plus 3. 2 into bracket x plus 3. That is what is going to give you as a value. Now, we can now, after we have been able to get the value of the u dx and the v dx, then let's now apply our product rule. Product rule says that the y dx will now be equal to v du dx plus u dv dx. U dv dx. Now, what is the value of our dy dx now? The value of our v is what? Our v, x plus 3 raised power of what? 2. The u dx, what's the value of the u dx? Our du dx is this, the u dx, half 1 over 2 x raised power of minus 1 over 2. It is power. Then you close this bracket like this. Then what is our plus? Don't forget, this is plus u. What is the value of our u? X raised power of half. X raised power of half. Multiply by. You can put dots there. dot there, multiply by the VDX is 2 into bracket x plus 3. Now you close the bracket like this. Now you will discover that this value can be turned into root x, 1 over root x. So we can now say that the ydx is equal to x plus 3 squared 1 over 2 multiplied by 1 over 2 times root 1 over root x. Because why do I have this there is that this negative value here has turned into reciprocal of this x, and this 1 over 2 as the power level, this is the one that transforms into root of x. So that one close it there. Then this one as well will be equal to is just power of root x multiplied by 2 into bracket x plus 3. Close the bracket like that. So we are having this one like this here, which means that we can now expand this bit to be equal to the x will be equal to x plus 3 squared. This one is also over 1. Multiply by 1, multiply by 1. That's what? X plus 3 squared. All over 1 times 2, 2 times root x. That's 2 root x. I close the bracket. Then I have another one, which is what? 2 root x into bracket x plus 3. Plus, don't forget, plus, there's plus here. There's plus there. Plus 2 root x. I say 2 times root x here into bracket x plus 3. We close the bracket. Now, you can open up the bracket right now. We have the ydx will be equal to x plus 3 squared over 2 root x plus 2 root x into bracket x plus 3 over 1. Now, when you have a fraction, you can say this is a fraction, this is another fraction. So if you have a fraction and they are separated by a positive sign, you are going to find the LCM. What's the LCM of these two? That's 2 root x. That's the LCM of the two. 2 root x and 2 root x, that's 1. 1 times everything here, that will be what? X plus 3 squared. Plus 1 in 2 root x, that will be what? 2 root x. Multiply by everything here. That will be what? We have 2 root x there already. So that will be what? 2 root x squared. Because that is going to multiply with that one. Then into bracket x plus 3. So that is what we're going to have at this level now. Now, at this level now, we can now say this one is x plus 3. Don't forget, is equal to x plus 3 squared plus, now, 2 raised to power 2, because everything inside this bracket here will have the part of this power here, power of 2 here. 2 raised to power 2 is 4. Root 2, root x, raised to power of 2. But don't forget, whenever you have root, this particular value, power of 2 and square root, they will cancel one another out. So it makes that one to become only x now. Into bracket x plus 3. Yeah, the simplification is working towards getting the answer 2 root x now. Now, at this stage now, we can now open up this x plus 3 bracket. X plus 3 bracket will give us x squared. This will become x squared plus 6x plus 9. Yes. This one is going to be what? Plus 4x squared. 4x squared plus 4 times 3. That's all 12x all over 2 root x. So now at this stage now, we've been able to get the value that we can now look at what are those values that look alike and what are those ones. They will collect the like terms now. So let's do the collection of the like terms as we move ahead now. Now, I'm going to collect the like terms now. I'm going to have x squared plus 4x squared. 4x squared. What other like terms? 6x plus 12x plus 6x plus 12x plus 9 all over 2 root x, which is going to be equal to 5x squared plus 6 plus 12, that's 18x plus 9 all over 2 root x. Now, at this stage now, we've been able to, don't forget, we are still working on the y dx. The y dx, that's what we are still working on now. Now, at this stage now, you can see that this one, the numerator has turned into a quadratic equation, which is 5x squared plus 18x plus 9. Now, I won't say that it has turned into a quadratic now. We can now simplify it as well. So, how do we simplify it? We have 9 times 5 is 45. So, we are going to have 5x squared plus 15x plus 3x plus 9 over 2 root x. That's the y dx as well. So which we are going to have 5x into bracket. I take it into two parts now. 5x into bracket x plus can 5 go here? No. What can go between the two of them is 5x into bracket 5x plus 3, then plus 3 into bracket x plus 3. So all over 2 root x. Still on the y dx. So the y dx finally can be equal to 5x plus 3. Close the bracket, put the bracket there, another bracket, open it, x plus 3 all over 2 root x. 2 root x. That is the final answer for our divide dx. You can see the steps we take. That is why it is important for you to have detailed knowledge about most of these elementary mathematics. You can see here we make use of a quadratic method of solving this one by making use of factorization method. You can see there are some areas where we have applied the indices, different laws of indices. We have all put it inside. They are just application here. So as well, this differentiation too is an application in some other mathematics as well. So we implore you to subscribe to our channel so that you'll be able to have detailed information and up-to-date information and daily information as we post our question or our lectures online. Thank you and God bless.